Welcome to the session on Operations Management, Module 2, Lesson 4. We will be dealing about exponential smoothing method in this particular lesson. We have seen what is forecasting, what are the different types of forecasting methods, qualitative and quantitative type of forecasting methods. In quantitative, we have seen associative type of methods, where we have seen regression method, how regression method is applied for forecasting. Similarly, in time series methods, we have seen simple average method, moving average method, and weighted moving average method. Today, we'll see another type of time series oriented or time series related quantitative technique called the exponential smoothing method. This method also takes into account historical data and predicts about the future using quantitative measures. Let us see what this exponential smoothing method is, how it is applied, and how do we conclude, or how do we say that this particular method is beneficial to forecasters. Exponential smoothing method is a quantitative type of forecasting method, as already been told to you. The new forecast for the next period, let us say the next period is denoted by small t. So the new forecast for the next period t will be calculated as follows. So the new forecast will be equal to, that is ft will be equal to the last period's forecast, that is forecast is denoted by capital F, and since it is a last period, the previous period, since the current period is t, the last period will be t minus 1. So the last period's forecast plus alpha into last period's actual demand minus last period's forecast. So for all forecast values, we'll denote it by capital F. For the actual data or the actual demand, we'll denote by capital A. For the current time period, we'll allot small t, and for the previous time period, we'll say it is t minus 1. So your expression, mathematical expression for the new forecast for the period t will be capital Ft is equal to Ft minus 1 plus alpha into capital A for t minus 1 minus forecast of t minus 1. So here alpha refers to a smoothing coefficient or a smoothing constant, exponential smoothing coefficient or a constant whose value ranges between 0 and 1. You can see here the same equation, Ft is equal to Ft minus 1 plus alpha into At minus 1 minus Ft minus 1 is again rewritten as Ft is equal to alpha At minus 1 plus 1 minus alpha Ft minus particular equation. You can see here when I rearrange this particular equation here, Ft is equal to Ft minus 1 plus alpha into At minus 1 minus alpha into Ft minus 1. So it becomes alpha into At minus 1 plus 1 minus alpha into Ft minus 1, or in other words, the forecast for the next period is equal to, forecast for the next period will be is equal to, or the next period in the sense the current period which is under estimation. So don't get confused. The next period here refers to the period for which we are going to find out the new forecast. So here x is the smoothing coefficient whose value is between 0 and 1. X is the smoothing coefficient whose value is 0, between 0 and 1. It lies in the range of 0 and 1. And you can see here the forecast for the next period will be equal to, or the forecast for the next period will be equal to alpha into the actuals of the previous period plus 1 minus alpha of the forecast of the previous period. So you multiply the actuals of the previous period with alpha, add it to this particular term, which is 1 minus alpha, 1 minus that exponential smoothing constant into ft minus 1. So a very important feature of this method is that forecast made with this model will include a portion of every piece of the historical data. Unlike your previous moving average methods, where you're taking just the average of the current specified periods. In moving average, if it is say two month or a 2 year moving average, you are considering only 2 years. 3 year moving average only 3. But in this exponential smoothing, this is a much more developed, much more developed method, or which is much more with more features. So this is more clearer than the previous average moving average method. So this is just an improvement over the previous methods which we have discussed. So here this forecast will make use of every piece of the historical demand, all the previous data, because your new forecast is going to be some correction of the previous data. So all previous data with the correction, that alpha is the smoothing coefficient which is included in that particular expression. So this coefficient constant will smoothen out some of the fluctuations. That's the idea behind this exponential smoothing method. Also, there will be different weights placed on these historical demand values, with older data receiving lower weights, like your weighted moving averages. Here also, for the previous all the previous or the older data, you are giving lower weights, because you are giving more prominence, importance to the current data. So higher weights will be given to the current or the latest data, and lower weights will be given to the older data. So overall, this exponential smoothing is a very good method to find out the forecast for any number of data that is given, because in every step you are finding a new forecast based on the previous data, the actuals and the forecast of the previous times. So let us see how this particular method is applied to problems. So in this slide, let us take a problem and understand the. So here, these are the actual demand. A series of data for 6 years is given. So first year the actual demand is 310 and 365, 395 and so on for the 6 years. Now this value is not given. So this value was not given, this particular value. So this value we assume as 300 units. So this is a guess since there is no prior demand data given. So to find out the subsequent forecast, if the initial value is not given, you have to make a assumption or a guess. So in this case, I say 300 units, or it could be even any other value, which each one of you can have your own values. So based on your assumptions, the final value, the final solution will depend upon what first initial value I have assumed. So in this case, I have assumed 300 units. So when I assume 300 units as the forecast for first year, this is known, this is actuals. So this becomes now, if I have to find out the forecast for the second year, so this now becomes ft. So this becomes ft now, this becomes ft. So if this becomes ft, this becomes ft, this is ft minus 1 and this is at minus 1, and alpha value here is given as 0.1. So alpha is equal to 0.1. So how do you arrive at ft? Based on the previous mathematical expression which you have seen, alpha into 310. So 310 into 0.1 plus 1 minus alpha into 300, that is 310 into alpha, that is 0.1, that will be 31, that will be 31, and 300 into 1 minus 0.1, that is 0.9, 300 into 0.9, so that will be 270, that will be 270, that will be 270. How did you get this? I have to find out this data. So what I do, I will multiply the previous actual with the alpha value given. Alpha value given is 0.1. So 310 into 0.1 is 31, correct? 31 plus forecast for the previous term into 1 minus 0.1, that is 0.9. So this will be 270. So 270 plus 31 is 301. Similarly, if I have to find out for this particular value, this is obtained this way: 365 into zero point 0.1 plus this 301 into 0.9, so that will give you 307.4. How did you get this? 365 365 365, so this is 365 into 0.1, 0.1, so this is plus 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 this 301 301 301 into 0.9, 0.9. So if I add these two, I get this particular value. So 365, the previous actual into alpha plus the previous forecast into 1 minus alpha will give me this particular value, and so on. So for each value here, for each of this, I will find out the forecast values. So for this value, the fourth year, for the fourth year, so this is obtained this way: 395 into zero point 0.1 plus 307.4 into zero point 0.9 will give you this particular value. So this is how you arrive at each of the forecasts. So, and finally, when you come to this particular point, the seventh, your entire objective now is to forecast for the seventh year. The problem here is to find out the forecast for the seventh year. So here for the seventh year, as you proceed step by step, computing the forecast for each year based on the previous actual and the previous forecast, you will get this particular value. So once you calculate till here, so until you calculate all the previous forecasts, you cannot find out the forecast for the seventh year. So these things have to be completed here. So this 351, how did you get this? 465 into zero point 0.1 plus this 338.43 into 0.9 will give you this particular value. So your forecast for the seventh year will be 351 units. So this is how, please, students are advised to solve it. Take a notebook, take a pen, see the problem, how it is solved, and practice it on your own. Practice is the only way. Practicing, self practice is the best way to understand and learn problems, how to solve problems. So we are giving you guidelines here. You have to make use of the instructions and the discussions. We are now presenting to you how to solve a particular problem step by step. Go through the slide, go through the discussions, and solve the problem using a notebook and a pen. Do it yourself. Work out, and I think you will get 351 as a final answer for this particular question. So let us now discuss about the same problem using an alpha value of 0.2. In the previous slide, we used an alpha value of 0.1. Here it is 0.2. The procedure remains the same. The first assumption, assuming that the value is 300, initial forecast is assumed to be 300. It can differ from person to person. So in this case, we retain the same assumption which we have done in the previous class, or in the previous slide rather. Okay. So here 300 is the initial forecast which is assumed, and then you go on finding out the forecast values based on the previous actuals and forecast. So why this assumption in the first place is required? Because without this you cannot arrive at the subsequent forecast. So here this assumption is very important. Now if it is already given, mentioned that the initial forecast is say 290 or 300, you can use the same value with the organization says. And from the examination point of view, sometimes it will be given. Take an initial forecast of say 270, 280 or 300. If it is given, you can use the same value which is specified. If it is not specified, then we are free to assume. So in this case it was not given, so we have now here assumed it as 300 units. So now 300, and similarly like you have done previously, forecasts, that is here this value 302. How did you get this? 310 into 0.2 now plus 300 into 0.8, that will give you this. So you multiply this 310 by exponential smoothing constant, that is 0.2. You multiply this by 0.2 and then add that to this particular, this will be 0.8 now. How did you get 0.8? 1 minus exponential smoothing constant. So 310 into 0.2, that 310 into 0.2 will give you 62, a value of 62. 300 into 0.8 will give you 240. So 62 plus 240 is 302. That's how you have got this. Correct? So similarly, every point here, one by one, at every point, what you will do is you will find the subsequent forecast using this expression. What was the expression? The new forecast is equal to alpha into actuals of the previous plus 1 minus alpha into what was the value that you have to find out? 1 minus alpha into forecast of the previous period. That's all. Correct? So this is how you have got 387 here. This 387 finally you get. How do you get it? Again, once you calculate all this one by one, you have to calculate all these values using the same expression. Then 465 into 0.2 plus 368.035 into 0.8. So this into 0.2 plus 368.0352 into 0.8 will give you this 387. So this will be a final forecast for seventh year. So you can see here the difference. The forecast value for the 7th year using alpha is equal to 0.1 was a different value because alpha was 0.1. Here it is 0.2. So here you get 387.42816. So you can round off the decimals, either retain the decimals to 2 points or you can go to the next higher value. Correct? So different values of alpha. Now a very low value of alpha here is also not recommended, nor a very high value of alpha. So alpha usually should be in the range of say 0.4 to 0.7, something like that. But again, there is no hard and fast rule that it should be so and so. Organizations have different approaches to find the actual value of 0.2 depending upon the data, how relevant, how close the actual and the forecast matches. That is also equally important. So in our next lesson we will be discussing about the deviations, that is how can you judge whether which value of alpha is more useful or which is more recommended for the organization in the long run. So we have seen alpha is equal to 0.1. Now we are looking at alpha is equal to 0.2. We can still have one more exercise, same data with an alpha value higher than 0.2. Now which will be the best possible value of alpha for me? So if you want to make a selection, then you have to select that particular method or that particular alpha value which gives the least error. Correct? Which means the difference between actual and the forecast should be as minimum as possible. The difference should not be huge. Or similarly, two different methods, for example, two different methods also, which one to choose? Correct? Which method to use? Which method should I use? So you will be choosing that method which has the least error, which means where the actual and the forecast values are close enough. Correct? So this is how you evaluate the methods of forecasting. So let us take one more example of alpha and find out and see how the value of the forecast changes with the change in forecast value. So in this particular problem, the alpha value is assumed to be 0.4. So we have seen the forecast calculations with an alpha value of 0.1 and alpha is equal to 0.2. Here similarly I am assuming the initial value of 300. So here what happens, 310 into 0.4 plus 300 into 0.6. Correct? This is alpha value. Here it will be minus 1 minus alpha value. So 0.4, 0.6. Similarly, so this 310 into 0.4 plus 300 into 0.6 will give me 304. 365 into 0.4 will give me 328.4. Similarly, 395 into 0.4 plus 328.4 into 0.6 will give me 355. 415 into 0.4 plus 355 into 0.6 will give me 379. Similarly, 450 into 0.4 plus 379 into 0.6 will give me 407. Correct? And similarly, 465 into 0.4 plus 407 into 0.6 will give me 430. So the final forecast in this particular case will be 430 units. So you can see here, as the alpha value increases, the value of the forecast also increases, and we can also judge based on the differences here, and also the initial value. This is also very important, the initial value which you have assumed. Correct? You have assumed the same initial values here, but yet you get different values of forecast. So this forecast, this value of alpha becomes very important now. The choice or the value that you assign to alpha, that is very important. The organization will have its own way of finding out the alpha values. Now let us now see how you look at the errors and find out which method is more suitable than the other based on the errors present. So in our next lesson, once you have understood, since you have understood now, I hope you have understood the exponential smoothing method, practice on your own. Whatever problems you have discussed, practice it on your own. If you can also have an exercise here for, just assume a different value of 300, say assume it as 320, something more than 310. Here we have assumed the forecast is less. It is possible that the forecast could have been more than that. So in that case, how does the final forecast change, or is there any change in the pattern? You can do multiple assumptions. You can say it's the initial value. Try the same problem with a different initial assumption. Correct? Solve the three problems. Same problem with three different alpha values, like we have done now. So what it does is, you will also come to know that the actual and the forecast values, how is there any specific range in which it should lie? Now that's again because the forecast value is not in the forecast values are, yes, of course, estimated by the set values by the organization, but the actual demand is not in the hands of the organization, right? Actual demand depends on the market, the customer requirements, the changing attitudes, changing preferences of customers, the economic conditions. So the COVID, for example, you have planned everything well, something like a COVID or say a lockdown can severely hamper the demand, which is beyond the control of the organization. So this actual demand is not in your hand, but how robust, how reliable your forecasting method is, that can be judged by certain methods. So we will be discussing certain measures, rather not methods, measures, certain measures. So what are the measures to judge whether one forecasting method is better than the other, and what are the different measures by which you can say that the existing forecasting method which are employed by the organization should be continued or not? Organization sometimes might be continuing the same forecasting method for the last 10-15 years. Now, is there any way in which you can say that, or judge, find out any measure by which you can find out whether the existing forecasting method is reliable? Yes, it might have been good or reliable say some 10 years back, or is it reliable now? So based on the historical data available, based on the techniques known to you, you can find out by using certain measures whether the forecasting method that you are adopting now should be changed, correct, or should be refined. So that will be the topic for our next lecture or next lesson in module